All right, here we go. We're on page 68, which is graphing quadratic equations, and you'll notice there are steps to graph a quadratic equation. Before we did the sketch, so you already know how to find the axis symmetry, you already know how to find the vertex, which that's key right there. So we already know how to do steps 1 and 2. We're not going to use a graphing calculator, we're just going to do a little bit by hand. So on number 1, my first step, I still find that axis of symmetry. So A equals 1, B is 0, and C is 0. So x equals negative b over 2a is my formula to find the axis of symmetry. So I get negative 0 over 2. And does it matter? It's 0 divided by anything is 0. So my axis of symmetry is x equals 0. So now I can go over to my graph and I can sketch that axis of symmetry, and it's right on my y-axis, right? So to find the vertex, all I'm doing is that's going to be my first point on my graph here. So when x is 0, what is y? Well, when you plug in 0 for x, y is going to be 0. So there is my there's my vertex. I know it opens upward, so I can kind of look and see what points do I need to choose. I'm going to do these points by hand. Here's 0 and 0. We already found vertex. That's the first point in my table. So now all I'm going to do is I'm going to look for points. I know it goes upward, so I only want to deal with this part of the graph. So what I'm going to do is I'm going to do easy points. Let's find out what happens when x is 1. When x is 1, 1 squared, y is going to be 1. Now, because of this axis of symmetry, I'm going to work smarter, not harder. So I know if x is 1 here, it's going to be 1 over here because it divides it in half. So when x is 1, y is 1, and when x is negative 1, y is also 1. I didn't even have to work for that. I just used my axis of symmetry. And so now I'm going to find out, well, what happens when x is 2? 2 squared is 4. So when x is 2, y is 4. And if I go, so I went 2 units over on the right, so if I go 2 units over on the left, that's negative 2, and it's going to be 4 just like it is over here. And so when I sketch it, now I have points. So I filled in my table of values, I sketched it, I didn't sketch it, I graphed it now. Before I was sketching, now I graphed it. And now I'm going to answer some questions. What is the domain? Remember back from earlier in the year when we talked about domain, domain was all my x values. So it's going to go infinitely to the left and it's going to go infinitely to the right. So my domain is all real numbers because it goes infinite in both directions. Look at my range. Remember, range is how far up does it go or how far down does it go? Well, it starts at 0 and it goes all the way up. It's never going to go below. So y is greater than or equal to 0. 0 is a part of it and anything greater. So that is how you graph a quadratic equation. Let's do a couple more as examples together. And I know that I talk fast. So pause it, slow down, and make sure you understand. And I'm going to increase this to 200. All right, so let's take a look at number 2, okay? Axis of symmetry and vertex, you know how to do. Axis of symmetry, I'm just going to say A is 1, B is 2, C, although I don't need it, is negative 1. So to find axis of symmetry, my formula is x equals negative b over 2a. So I'm simply plugging in numbers. Negative 2 over 2. And negative 2 over 2 is negative 1. So my axis of symmetry is x equals negative 1. So I'm going to graph that over here. Here's negative 1. I'm graphing it, dotted line, infinite in both directions, so I have arrows on both ends. So when x is negative 1, to find my vertex, when x is negative 1, what is my y value? Negative 1 squared is 1. 2 times negative 1 is negative 2 minus 1. So when I combine all these, 1 minus 2 is negative 1, negative 1 and negative 1 is negative 2. So my vertex is negative 1, negative 2. So I know, so a couple of things I want to ask myself here. I know my parabola is opening upward. So do I want to pick points down here? No, that's crazy. because they're not going to go down. Because my parabola opens upwards, I'm only dealing with this part of the graph. So I'm going to choose easy points. The point that I see as easy is I'm going to say, okay, well, what happens when x is 0? Because here's 0 right here. So what happens when x is 0? Well, I plug it in. When x is 0 plus 0 minus 1, my y value is going to be negative 1. So 0, negative 1. So when x is 0, y is negative 1. Now remember we talked about that axis of symmetry. If this is negative 1 and it's 1 unit away from the axis of symmetry, then this is going to be negative 1 and it's 1 unit away from that axis of symmetry. So I'm not even doing any math there, but I do need to name that point. And that point is negative 2, negative 1. So when x is negative 2, my y value is going to be negative 1. All right. Let's see what happens when x is 1. What happens when x is 1? So I'm simply going to plug in 1 squared plus 2 times 1 minus 1. So I get 1 plus 2 minus 1. 3 minus 1 is 2. So when x is 1, y is 2. When x is 1, my y value is 2. Right? When x is 1, my y value is 2. So I'm going to use this axis of symmetry to help me. Well, if it's 2 units away over here, it's going to be 2 units away over here because it's a reflection. And now all I do is I need to name that point. So that point is going to be x is negative 3, y is 2. So this point is negative 3, 2. And I filled in my table of values. And I can look at my graph, and it looks like that, parabola. Now what I'm going to do is I'm going to label my domain. My domain is infinite in both directions. It's going to go all the way left. It's going to go all the way right. So my domain is all real numbers. And my range is here. It's going to be y is greater than negative 2 because this point is negative 1, negative 2. So y is greater than or equal to negative 2. Let's do one more. All right. Let's go down here to a negative. All right, so let's look at number 4. All right, axis of symmetry we know. So A is negative 2, B is 4, C is 1, although I don't need to know. So x equals negative b over 2a. So I get negative 4 over 2 times negative 2. And that's negative 4 over negative 4, which is a positive 1. So my axis of symmetry is x equals 1. X equals 1. And over here I'm going to graph it. My axis of symmetry. Yeah, that's right. X equals 1. Okay, so I've graphed my axis of symmetry. I'm going to find that vertex point. So now I'm just going to plug in 1 for x and solve for y. So I get 1 squared is 1. 1 times negative 2 is negative 2. 4 times 1 is plus 4 plus 1. So negative 2 plus 4 is 2. 2 plus 1 is 3. Okay, so my vertex is 1, 3. So I'm going to go 1, 3. There's my vertex. Now, look at my leading coefficient. It's negative, so it's going to go down. So I want to look at these values over here. Okay, so I'm going to make it easy on me, and I'm going to look at, okay, what happens when x is 0? That's an easy point. If I plug in 0 here, this term 0, this term 0, and 0 plus 0 plus 1 is 1. So when x is 0, y is 1. And now I'm going to use that axis of symmetry and save me some time. If it's 1 unit away over here, it's 1 unit away over here. But I must name that point. And that point is 2, 1. So when x is 2, y is 1. Right? Let's use a different point. Let's find out what happens when x is 3. What happens when x is 3? And I can choose any point I want. So negative 2, 3 squared plus 4 times 3 plus 1. So I'm just going to evaluate. Remember, order of ops. 3 squared is 9. 9 times negative 2 is negative 18 plus 12 plus 1. So I've simply evaluated. And negative 18 plus 12 plus 1 is negative 5. So when x is 3, y is negative 5. 1, 2, 3, 4, 5. And because of the axis of symmetry in that relationship, I know that this point is going to be 2 away from my axis of symmetry. So it's going to look like that. But I've got to name that point. And what is that point? It's -1, -5. So when x is -1, y is -5. And here is my graph. So my domain, it's going to go all the way left, all the way right. So it's all real numbers. And my range, look, it's up here at 3, but its y is less than or equal to anything below 3. It's never going to be greater than 3. Always 3 or below. Okay, so that's how we graph in standard form quadratic equations. Good luck.